Mr. TG. I'll be your Algebra 2A instructor. Our first lesson of Algebra 2A is given to us in section 1.1, and the title of the lesson is Patterns and Expressions. What I'm going to do is have you work through the guided notes with me. I'd like to have you write it down on your sheet of paper that I provided and bring it to class the next day. And hopefully, after listening to this presentation, you'll have a very good understanding of what this lesson is all about and what it's trying to accomplish. So we'll start with the variable with the terms in this lesson. There are three of them: a variable, a numerical expression, and an algebraic expression. A variable, as the book likes to define it, is a symbol used, usually a letter. In algebra, we're going to use the letters X, Y, Z, N quite often, but any letter of the alphabet can represent one or more numbers, is called a variable. Numerical expression, as you can see from the definition, is just a mathematical phrase using just numbers. And an algebraic expression is very similar to the numerical expression, except it has variables. So those are our three definitions. What we're going to do next is show you an example that the book provides us. And that particular example will force us to set up a table, look at patterns, and then create an algebraic expression, which means now we're going to have variables along with numbers that are either being multiplied, added, divided, or subtracted to create that pattern, and then it's going to help us answer the question. So here's the problem. It says express a pattern with algebra. Use the pattern to answer each question. How many toothpicks are in the 20th figure? As you can see here, in the first diagram, we have 4 toothpicks. The second one, we have 8. The third one, we have 12. So what I would like you to do is create a table like this. Our first column is going to be called the input. That's the figure number that you're on. The last column is the output. That's how many toothpicks we're going to end up with. And the middle column is called the process column. That essentially is how are we going to get the output from the input. Now this is a fairly simple problem because as you can see, if we multiply the input by 4, we get the output each time. That is our pattern, and that's what the process column helps us calculate. Now what we're going to do is assume it's the nth figure. We now take it times 4, and we created our first algebraic expression. This is 4 times n. Please don't put the multiplication sign in between. Multiplication is assumed to be there with 4n. Now we're in a good position to answer our question. What's on the 20th figure? How many toothpicks are in the 20th figure? Well, it'll be 4 times 20, which is 80. So we've answered our question using a table that consists of an input, an output, and a process column. Now, what I'd like to have you try to do is answer the got it. I'd like to have you make your own table with an input, a process column, and an output, and spend some time on this and try and think about how many tiles are in the 25th figure using that same strategy. I do not want you to draw 25 shapes. I want you to make a table, look for a pattern, and use that skill to help you find the number of tiles. So I'd like to have you at this time hit pause and make an attempt to do this. When you're completed with that, you can come back and I'll have the answer for you. Also, please remember that in this class, you learn more by trying it first and then learning what you need to do afterwards rather than just copying my work. So make an effort, give me some effort, give me an input, and it will help you out tremendously. So hit pause and come back to this when you're done. So welcome back. Here is how I set up my table. Yours might look a little different, but this is fine as long as you have 3 columns. We have the input, the process column, and the output. We do have a special name for the input. It's called an independent variable. It's something we'll use in the future, so be aware of that. I might as well put that down in your notes because it's something that we'll use. The output, we like to call that the dependent variable. The output represents the y-axis on a graph. The input represents, the independent variable represents the x-axis. And the output depends on the input. So our first diagram has 1, and of course that's 4 tiles, 2, 6 tiles, 3, 8 tiles. As you can see, the pattern here is we're multiplying by 2 and then adding 2. 2 times 1 is 2 plus 2 is 4 tiles. 2 times 2 plus 2 is 6 tiles. 2 times 3 plus 2 is 8. So now, if we represent this, have n as our input, then 2n plus 2 is going to be our output, and then our output for the 25th figure would be 2 times 25 plus 2, which would be 52 tiles. Hopefully that went well for you, but if you did not get it correct, please make the change, adjust your notes so that you have correct notes to look at. Our next question that I selected was out of the textbook, and this basically, you're not supposed to see that yet, but here's what I've got. I've got a three columns again to help us. Again, I call the input the independent variable, the output the dependent variable, and then the process column. Now, we have an aquarium here, and you want to set up the aquarium, and you need to determine what size tank to buy. The graph shows tank sizes using a rule that relates the capacity of the tank to the combined lengths of the fish it can hold. And what that means is if you look at the x-axis here, these numbers, these represents the total length of your fish. So if you buy 2 fish that are each 3 inches long, that would be 6. That's where you would be. That's not the case in here. We're going to buy 5 2-inch platies, 4 1-inch guppies, and a 3-inch loach, which is the smallest capacity tank that you can buy, 15, 20, or 25 gallons, and use a table to find the answer. So here we go. Now this one doesn't specify which ones. I mean, we got plenty points here on our line that we could use. The first one I picked, and you can pick any of them, would be 0, 1, or 0, 2. This simply means that if our fish length is 0, we're still required to have a 2-gallon aquarium. The next one is 4, which means, as you can see from I got this right off the chart, 4, 6. I went over 4 and up 6 right here. Up 6, and that means if my inches, the fish lengths add up to be 4, we now need a 6-gallon capacity aquarium. The next one that I selected was 8, and of course if our fish length is 8, now we need a 10-gallon aquarium. And then I run out of graph. So now it's time to create a pattern from our process column so we don't have to extend our graph any longer. And as you can see, it's a very simple calculation of adding 2 to the input to get the output. So our expression that we're going to use is n, n plus 2. And then the only tricky part of this problem is to make sure that you represent n as the total length of the fish. We have 5 2-inch platies. We have 4 1-inch guppies, so 4 times 1, and 1 3-inch loach gives us a total of 17. And then we add 2 to that, and so we require to have a 19-gallon tank. And unfortunately, they don't sell a 19-gallon tank, so we'd have to buy the next one above that, which would be 20 gallons. That completes our last problem of section 1.1. Hopefully this it went well for you. Again, make sure you have the notes. Make sure that they're all filled out. And then hopefully you'll come to the class prepared to complete your assignment. Thank you.